This video is brought to you by Sporlan, quality, integrity, and tradition.
Well, we had a call on this a couple weeks ago, and we found that the whole indoor blower assembly had blown apart inside of it. So we've got a bunch of parts here today, and we're gonna get this guy back up and running. So let's get into it. All right, with some careful understanding of how these units come apart, we basically pulled apart everything that we're gonna need. We're gonna replace this entire blower assembly. You can see the blower wheel just disintegrated, grenaded in there. We've got a new motor bracket. There's a retrofit one. We've got a new motor, and we have this motor base plate right here because this one has a giant crack, of which I'll show you once we get in here, but there's a huge crack from the vibration. So we've got that plate too. So take this whole thing apart. It's a chore to say the least. Look at that. Belt stuck down in the drain pan. So we got some stuff to clean up also. Understanding how these units work is really important, but we got it all pulled apart. I've done a bunch of these, so it's kind of cookie cutter at this point. And we're just vacuuming out in here now, trying to get as much of the dust and dirt. We'll do the same over here. The condenser coil is clean. I can see down into there. There's like a little bit of lint right here, but I can see through that thing. We'll get a new zip tie on it because this one busted. Get them pulled back together. But yeah, we're looking good there. So it's just a matter of knowing what screws you got to do. Just looking, paying attention. There's a couple in here that screw the deck fan down. We'll vacuum this out. We're not doing a heat startup today, but we'll do our best since we're cleaning to get in here. You also got to be careful because this heat stuff gets worn out, so you can't really dig at it with a vacuum because it'll poke holes. It's really, really bad shape, but that's looking pretty good. Definitely got some wire management to do when we're done. We'll get the drain pan vacuumed out, and then, like I said, the other side, and start assembling this thing. Assembling this, you know, takes a minute, but just a little bit at a time. Everything goes together to make it hold itself together. We're about to put the blower assembly on. I removed the economizer plug because it was disconnected anyways. So we're gonna pull it back here and eliminate it, so that way it's no more crap ton of wires running over the blower. We're only gonna run what we need to run, which is the 3-phase for the motor, the freeze stat, and then the heater limit safeties, and then everything else will be back in that way in the board. So we're moving along a little bit at a time. We've got a old blower, we have a brand new blower. So when you get in the 5 and the 6 tons, they have the pre-built blower assembly, so you don't have to order them in parts, so that's really nice. And then we got a new motor bracket for it too. I had to special order this motor bracket from the factory, had to have them next day it, and it's missing parts. So there's no nuts and bolts to assemble it. I went through this whole box right here, nothing there. And there's supposed to be a piece that goes under here because the old school motor plate was flat and it bends and is a problem. So this piece goes on here so you can tighten it, right? And then this piece goes on the side, and then there's supposed to be a small like 6-inch piece to go under here, so that way this motor bracket sits like this with a motor on it. And it's missing the other plate and all the nuts and bolts and everything that hold it together. That's freaking frustrating. Again, we next day aired this from the factory, from Carrier. That's pretty ridiculous that it's missing all that stuff. So, gosh darn it, I'm gonna have to use the old motor plate. Blower assembly in, motor bracket, we had to use the old one, like I said. The reason why we replace these is because they flex. When you put the motors on them, this already has a little bit of a bow. And the new style doesn't do that because it's a different setup with 2 pieces. You can see this one's set up for the new style. So you affix this bracket, that's the piece that's missing, and then the new bracket sits on top of it. But whatever, it's just one of those things. We'll have to return it. So we're gonna clean up this wiring for the freeze stat. We'll make sure that's in a good spot where it's not gonna rub out. And then we're just getting the motor undone so we can wire in the motor on this guy. Most of the time we don't have the top off the unit, so we don't have the luxury of staring at the way that the belt is riding in the pulleys. Now this is not ideal. So what's happening is this motor bracket is no good, and this is why I wanted to change it. Now watch, I'm gonna take this off. Watch what happens to the motor bracket. Look at the motor. Look at the base of the motor right in here. When I put this belt on here and it pulls on. Now you're not supposed to stretch a belt, but this is the point. When you put tension on it, it bows the motor down. You see how the pulley's moving when I put that tension on there? Look at the whole motor's flexing. So when we put it on there and we tighten it up, and it's not even that tight, and we tighten it up, so you know, we got about, I don't know, an inch of deflection. Nothing is straight now because the whole motor bracket is bowing down and it just has too much flex. And that's the downside of this motor bracket. That's why it sucks. The funny thing is typically we have the top on the unit, so you can't see that. So you just see like right here and you're like, oh, that looks pretty good. But it's really not aligned properly and it's gonna wear out pulleys faster than it should. But this is just a smaller unit that doesn't have a lot of adjustment. Now, even when you get the new motor bracket on there, they're still kind of wonky because this can be out of whack too. Even though we replaced it, it had some bow to it, so that can be out of whack too. Nothing on these units is like perfect. So, all right, we're wired in. We're gonna start zip tying the wires up and getting ready to bump start this so we can check the rotation. We wanna do a quick phase rotation test. So we want this blower to spin counterclockwise. I have R disconnected and I'm controlling it via this jumper wire. So go ahead and turn on 3-phase power. Should go. Turn it off. Okay, we are going the wrong direction, but that's fine. We can reverse the phases. It's not a big deal. Over here, we just need to interchange, if we can, 2 of the wires. I'll find them and we'll switch them over and then see if we can't get this guy going in the right direction. All right, I switched them up. So let's jump it again and see what happens. That's the right direction now. So now we are going in the right direction. Now we haven't set our blower speed yet. I put the pulley, matched it up as good as I could to the other pulley. So we're probably gonna be within range, but everything's protected. The wires are zip tied up so they're not gonna rub out. You can see even this, I have this freeze stack control wiring zip tied up to where it's not rubbing out on any metal. Even when it comes around the corners, it's not rubbing out. It's being held by the zip ties. So we're ready to put the top on this unit and then we can kind of figure everything else out. The economizer, I pulled back all the wiring. It was already disconnected. Literally all the wires were just loose and someone had pulled them out over here. So I just pulled all the wires out, eliminated that from our possible problems in the future. And we're gonna keep going with this. Blower is now running in the right direction. We put all the panels on. We tested current. It's running at like 4 amps. We're allowed to run 4.2 or 5.2. I set it where the other one was set. So we're gonna leave it where it is. And we're gonna go ahead and probe up and test the refrigeration circuit. Now, when I diagnosed this, I made sure there was refrigerant in the system and I just bumped the contactor for the compressor to make sure it ran. Once we ensured that worked, there was nothing else we could do to check the charge or verify restrictions or anything like that because the blower assembly was dead. So we know the compressor works. Whether or not the refrigerant charge is right or, you know, refrigeration circuit's doing good, we don't know. So that's what we're about to test right now. So sometimes, you know, you got to warn people in your quotes and your estimates. Like I told them, look, we got to change this blower assembly. We have no idea what's wrong with the unit and we won't know until we fix all this stuff. So on units this old, it's kind of Pandora's box. This is a 2003, I think. 2004 unit, 4404. So this is 20 years old. So, you know, the odds of something else being broken are pretty good. Well, it is kind of as I expected. Look at my suction. Look at my saturation temperature, 17 degrees. We're definitely have something going on. It might be slightly low on refrigerant. Subcooling, I would expect it to be in the 20 range because we're using discharge pressure. So we'll have to dig into that. We got our evaporator above freezing, but we definitely have a restriction in the system. Okay, first and foremost, my superheat did drop. This is a fixed orifice metering device, so you treat it as a piston. It has actuator metering devices in here. There's little liquid headers in here. It's kind of hard to see back there. But those little lines that go this way, behind that pipe, those are the metering devices. There's a bunch of individual metering devices. This guy right here has a bunch of little restrictors in there and they are slightly restricted. So we got to give it a minute to settle down, okay? But where it was at, what I do is we're using discharge pressure, okay? This is a fixed orifice metering device. On this stylus system with the condenser that it has, there's about approximately a 35 PSI pressure drop from the discharge line to the liquid line, okay? So if we want to know what our true subcooling is, notice it says 19 right there. If you subtract 35 from this, find a PT chart, find the pressure temperature relationship with the new pressure, and then subtract 96 degree liquid line temp, you will come up with 9 degrees of true subcooling on this unit, okay? With 9 degrees of subcooling, I've got a 35 PSI, I've got a 35 degree compressor superheat, and this is a fixed orifice metering device. We're looking for 7 degrees, okay? But I did put a little bit of gas in there, but we don't want to put too much because I might be able to go just a little bit higher on the subcooling, but essentially we got our evaporator above freezing, the saturation temperature, but we don't have proper compressor cooling coming back because we're at 35 degrees superheat. So in the long run, they're going to overheat the compressor because this guy has a restriction in the metering device. Pretty typical on these carriers. I'm gonna put just a little bit more gas in there. We'll get our subcooling up to about 10 or 11 degrees and see what that does for us. But yeah, it's gonna be not perfect, right? But it'll operate and it'll function. So we're gonna let it run a little bit more and stabilize it. Now, if I suspected that I have a refrigerant leak, why did I add, if I suspected that I have a restriction in the metering device, why did I add refrigerant? Because when I took off the caps, this one right here was leaking refrigerant, just spraying out for the low side. So I know it's slowly leaking. These caps don't hold back pressure. When I pulled it off, it was literally hissing. So I know it's going to be a little low on refrigerant, but at the same time, we're not just dumping refrigerant blindly. We're paying attention to the subcooling, and we don't want to go too high on our subcooling. You can see that we're almost within our targets, but we're definitely nowhere near where we should be for our superheat. So this guy's not going to be perfect, but like I said, I think it's going to work. What about the rest of the performance of the unit? Approach temperature, looks about, airflow is a little low, 1500 CFMs. It's probably got restricted ductwork, I can guarantee it. Temperature split's about 25 degrees. Delivered capacity is about 62,000 BTUs. We're calling for 68. I mean, this thing's all within range. It's just doesn't have the proper compressor cooling coming back at 30 degrees superheat. That is a problem. But that'll just be something they're gonna have to deal with unless they let me change the evaporator, compressor, clean the condenser inside, not the outside, but clean the inside of the condenser out. There's just dirty oil in the system and it's plugging up the metering device. All right, I've got my subcooling to about 13 degrees and that's about as high as I want to go, because anything past that, we're just stacking excess refrigerant in the condenser. So let's see what Measure Quick has to say. Suction line temperature is too high. That's exactly what I'm saying. Sensible capacity below 90, it's cool in the building. System may be undercharged and there may be a restriction in the liquid line. So it's everything that I was kind of thinking. This is about as good as it's gonna get. You can't see visible frost on the metering devices. When they're really restricted, you can usually see frost, but that's about as good as it's gonna get. You can also see that they're missing a cover on this compressor. It's not in here. This is what I'm talking about. When I pulled the cap off, it was actually off the discharge line. It's leaking out. So what I'm gonna do is we'll replace both of these. I'll go get my tool and we'll go get some Cormax fittings. Oh yeah, that's not even holding it back. These things stink, always leaking. Okay, that'll slow it down for the moment. We'll replace both of those Cormax fittings right now. All right, so we've got a leaking fitting. I broke it free with my wrenches right here. Just slightly, pull this out, slide that on. Got to make sure it grabs. And if it doesn't grab, you got to make sure you really get it on there. There we go. Now it grabbed, okay? So now what we're gonna do is push this down and untwist, and it's gonna be, the pressure is gonna wanna push it up. And it's kind of a pain. Just gotta go slow, pushing it, and eventually it'll pop out, but you just gotta make sure that it grabbed, like right here on the quick release, because last thing you want is for it to pop off in your face. So let's see. You can usually feel it because it'll click when it's out. I'm not feeling the click yet. Should be out though. Alright, we're gonna go ahead and give it a shot. Ball valve it off. The only thing this doesn't have is a bleed port because there's pressure in there and it wants to pop off. You gotta blast it out the gasket like that. Okay, there it is. So there's you can see how nasty that oil is in there. It's trash. Okay, we got a new one right here. Just slide this in there. Slide this in there. Pull it back. And we're gonna push it down in. Oh, I'm gonna get this up. If you were smart, you put like a 1/4 inch ratchet right there and then you can just tighten it on really quick. But I'm not that smart. There we go. It's snug, it doesn't want to come out anymore. Ball valve it off. There we go, it's out. It's out. Now we just torque it on. So just grab a 9/16, grab this. It's good. Now it's good. We'll do the same for the other one. And now we've got the old Cormax fittings replaced, new ones installed, leak-free. We're gonna put the panel on, and like I said, we're gonna wrap this one up.
So this video was actually filmed in September of 2024, right at the end of the summer. This was like one of the last big heat waves we had. We still had a little bit of warm weather after that, but this was like the last one. I've just kind of been sitting on this footage because it never really panned out. And then as we went through the winter, it was kind of weird. We're kind of coming out, heading into spring. We still got some cold days. It's actually raining today, but with this video, we run into a lot of these old Carrier units. This was an old Carrier unit, R22, 2004, and we still have more R22 units out there than I have 410A units. It's really, really difficult. I get a lot of people asking me all the time, why don't I just replace the units? It's really difficult to get units replaced in California, especially to do them right, because of what the municipalities, the local cities and code department and all that different crap, building services, whatever you want to call them, the requirements they have for these customers to change equipment. Oftentimes the customer would rather opt repairing it. Okay. It's not really my thing to really tell the customers, and I'm not going to flat out refuse to work on something. As long as the customer's paying my bills, I'll keep doing what they want me to do. You know, so it is what it is. But we did our best. We found that the unit had a bad blower assembly, and I know that on those little units, I can just get a whole new blower assembly for it. Don't even have to do anything. So we did that. We also changed the deck. They call it the deck fan, the piece that the blower assembly sits on. It was kind of a bummer about the motor bracket. But it is what it is. And I was able to get my local Carrier distributor, which is Sigler. I was able to get them to go ahead and waive the next day air freight. They gave me all my money back for that motor bracket. And we actually went ahead and left it with the other one because I brought it to the customer's attention and they didn't want to have to go through any more stuff. So they just said, just leave it like it is. And the unit's still running. Now, as we're coming into the cooling season, right? Because currently it is March. I don't know if it's like March. It's the beginning of March. I don't remember exactly what day it is. I lose track of time when it comes to this stuff. We're so busy right now. And it's crazy. Like, we're not so busy. It's just that I'm short staffed. So it just makes it harder for me to actually get in here and make videos and do office work and stuff like that because I'm having to go out and run calls, which is fine. Like, I genuinely like running calls. But anyways, going off on a tangent. I will say, though, if you guys are looking for a job, I'm looking for experienced and non-experienced. I'm also considering training an apprentice. Shoot me an email to just hvacrvideos@gmail.com. Shoot me an email and send me your resume and we can talk. But I prefer that you live local to the Inland Empire of Southern California because that's our service area. And we do have, you know, people coming into the office almost daily. So I don't want people having to drive an hour, hour and a half into the office. That's not practical. Plus for emergency calls and stuff like that, it's just better that you live in the Inland Empire. So anyways, if you're interested, shoot me an email, hvacrvideos@gmail.com. Okay. So back to the video. Really common on these units for the carrier actuator headers to plug up. Okay. Oftentimes it's because normal routine maintenance isn't being done on a regular basis, but I will say there's a design flaw in these units, and that's the double road condenser. The double road condenser leads to a lot of premature issues on these units. If this unit had an expansion valve system with normal distributors, you know, they wouldn't have the problems that they have today. Okay. And if it didn't have a double road condenser, I should say. But even just an expansion valve on this system would make things tremendously better. Then I know a bunch of people out there is going to tell me, well, why don't I convert this to an expansion valve? Because there's not a kit. Okay. And I'm not really one to go out there and try to field engineer it, make my own system. It's just not really my thing. Okay. Everything that I do has to be repeatable by my employees. I don't like coming up with, you know, fancy ways of doing things and then not being able to have my employees do the same work. Okay. So, you know, we don't really try to get in there and re-engineer things very much. I'm not saying I never do it, but yeah, if they made a kit for this that I could order from Carrier that came with an expansion valve and it was a full retrofit kit, sure, I would order it, but they don't. Okay. And if they do, as far as I know, they don't. I've done all my research. Okay. I've said this on several videos, and a bunch of people have reached out to me saying, yeah, they do, but then they can never provide me a part number, nor can Carrier find a part number, nor has anybody been able to provide me with that retrofit kit. If you know of it, let me know, because I could sell those things all day long. Bottom line though, when we have the double road condenser and the double road condenser gets forgotten, especially on the bigger units, because these smaller ones, it's easier to pull the top off. The bigger ones, it's even harder, right? And you can technically kind of lift up the top, but as these units get older, it starts to buckle and then it'll bend. So if you go to any of these Carrier units and you see the bends where the flange part going down on the top is rippled out and it's got like a fold in it, that's because someone tried to clean the double road condenser without taking the top off. And I don't like that. That drives me nuts when I see that. So if I can do this, I prefer to pull the whole top off the unit. So that means pull the condenser fan motors out, pull the whole top, then you can get in there, properly clean it, and do everything you need to do. Okay. Now, hopefully you guys understood the point of why I was saying this unit had a restriction. I know that a lot of people are going to push back on that. Okay. But trust me, there's something going on in those metering devices. And I basically didn't want to put any more refrigerant in there because we had massively high superheat. This unit is a fixed orifice metering device, has a ton of those little pistons in there, right? It's actually not even piston. It's two restrictors. And that's the other thing too. It is not possible to clean these restrictors. Okay. I know, I've tried it. I know a bunch of people say that it is, but I challenge anybody that's cleaned these restrictors to, the next time you change one of these evaporators, cut that restrictor out and cut it in half and look at it. You have two little itty bitty orifices that are about a ½ inch apart. Okay. So let's just say that you put a bunch of nitrogen on one side and you heat it up with a torch, because that's what a lot of people think. You heat it up with a torch and then you melt whatever wax you think is in that restrictor, right? Then once it gets through the one restrictor, it then now has to get through the other one. And that's not really going to happen. Okay. The way that it works, it just doesn't make sense in my head that these things are actually cleanable. Now, to each their own. Okay. If you can do it and it works for you, so be it. I have never been able to successfully clean these fixed orifice metering devices on these things because of the double restrictor. It just doesn't clean and you just always have problems. Plus, on top of that, if you get it clean, you need to clean all the residual nasty oil out of the system. So that means change the compressor, okay, and scrub the walls of the pipe all throughout the system. So that way when you put the new one in, it then doesn't plug up right away. And granted, if you change the compressor and you go to an alternative refrigerant, 407C or whatever it may be, and again, let's jump on that high horse too, where a bunch of people are saying you don't have to change the oil. That's bullshit. I'm sorry. You have to change the oil, okay? You're just going to run into nothing but problems, okay? You're just leaving a problem for another person. Don't trust any of the manufacturers of those refrigerants that say their refrigerant works with polyester oil. It doesn't, okay? If you read deep down on pretty much every manufacturer that I've looked at that has an alternative to R22, in the fine print of their documents for their refrigerant, it says, if you have high pressure drop situations, if you have this, if you have that, it's best to change the oil to polyester oil. It'll some kind of fine print legal jargon, okay? All the marketing materials that all these manufacturers have that say their insert name of whatever refrigerant works perfect with R22, you know, without an oil change and all this different stuff is baloney, okay? They don't, all right? On some systems, I will say that you might be able to get away with it, but it's not right. And it's not going to work right, and it's just going to lead to headaches. Your best bet is if you're going to use something besides R22, you need to convert the oil. On top of that, in this situation on this video, that system has been severely not taken care of for a very long time. Therefore, the oil in that compressor is more than likely completely contaminated, okay? So that compressor is probably not repairable, because you're not going to pull the compressor out to dump the oil out, to put new oil in it, to put it back in. That's just going to be a nightmare too. You might as well just change the compressor. But if now this compressor is newer, so it already had polyester oil, okay, which is what I'm getting at. But if you have an old mineral oil system and you're going to change it over to polyester oil, another thing you're going to realize is that polyester oil acts as a solvent, and it's going to scrub the pipes of that system. When you put the new compressor in with the polyester oil, it's going to flow through the system and it's going to scrub the pipes, and then that stuff has to go somewhere. And more than likely, as it's going through the entire system, it's going to make it through the dryer if it's not already past the dryer, and it's going to plug up those restrictors again. It's just a double-edged sword. I've got evaporators that we've changed compressors on these identical units where we've changed the compressor and the evaporator. You start it up and it runs great. 3 to 6 months from there, plugged up restrictors again, clean condenser. It's just once these systems get to the point of total contamination, you're just playing whack-a-mole, really. Like, that's all you're doing. In a perfect world, the customer replaces this, right? But like I said, they didn't want to. So it is what it is. I'm going to keep repairing it, obviously, as long as they're paying my bills, right? So of course, I always try to get them to replace equipment, okay? Even with this, I said, hey, this unit's in pretty bad shape. What do you want to do? Let's just go ahead and repair it for now, right? Again, okay, to each their own. That's their decision to make, and I'm fine with that, right? As long as they're paying my bills and as long as in my fine print, they understand that, hey, you know, there could be some other problems. This thing is 20 plus years old. It's really time to replace, but they want me to keep repairing it. I'll keep repairing it all day long. As long as I can get coils for it and, you know, compressors for it, I'll be fine. Now, my personal preference on these units, especially with the fixed orifice metering devices, I have not had good luck with alternatives to R22. I prefer to go back with R22. We still use it to this day. It's obviously expensive, but I've had the best luck with it. Now, using things like 407C, I've ran into problems with the fixed orifice metering devices when we get into the really, really high heat of summer when we're hitting above 115 degrees. I have just all sorts of issues where these units will operate perfect in normal conditions, great vitals, but the moment that the condensing temp gets really high, something happens and they just run into problems. Now, that's my personal experience on fixed orifice metering devices. I will say on systems that have expansion valves, I've had extremely good luck using 407C. So big Linux package units that have expansion valves and we have repairs we need to make, yeah, we typically convert it over to 407C as long as we have the right oil in the compressor. And we've had nothing but good luck on expansion valve systems, but I've had really bad luck on fixed orifice metering devices, okay? That's just my thing. You know, if you've had good luck, good for you, okay? So I'm not perfect. I'm not the best. I just try, okay? That's all I can do. And I try to give my customer the best bang for their buck, right? They're spending a lot of money with me, so I try to be open with them, honest with them, and give them the best value for the money that they're spending when it comes to my service work, okay? Hopefully, I didn't irritate anybody with my words and my comments and all these different things, but this is just how I choose to operate my business, okay? Yeah, if I missed anything, feel free to shoot me an email, hvacrvideos@gmail.com, or leave it in the comments. I'm always good. If you have criticism or anything like that, put it in the comments. I'm totally down with that. As long as you're cool about it and you're not a jerk, I'm totally open to criticism, okay? If I'm wrong, if you see something that I completely did wrong or something that I said is flat out wrong, let me know in the comments, okay? I'm not afraid to have that stuff in the comments, just so long as you're not being a jerk about it, okay? Maybe I can learn something, right? Maybe I'm just a stubborn butthead that isn't willing to accept change or something. Let me know, okay? Again, thank you so very much. If you're interested in supporting this channel, there's a couple different ways you can do so. If you want to go to my website, hvacrvideos.com, we have merchandise available, such as these hats right here, stickers. We still have a few beanies, sweatshirts and t-shirts, but the sweatshirts and t-shirts, we're phasing those out. We're just going to stick to the hats, the beanies, and the stickers in the future, right? But again, hvacrvideos.com. But you know, the easiest way to support this channel is literally just watch these videos from beginning to end. That really is the easiest way, okay? You can also support it via PayPal, Patreon, or YouTube channel memberships. There's links in the show notes of this video. And last but not least, you can go to truetech.tools.com. Now, one thing I didn't cover that I'm sure a lot of people were triggered about was the Cormax tool that I used. I know a lot of people hate those Cormax fittings. Hey, you know what? They're silly, but they're on the system, and I change them, right? I personally don't like putting service tees on them because it creates a restriction. If I can use that Cormax fitting to the proper way and it gets worn out and I have to replace it, then so be it. I have the tool. Yes, the tool is like $600. It's something silly. It's ridiculous how expensive that tool is, right? For not having a bleed port, for not being able to remove the core to pull an evacuation. It's ridiculous, but it is what it is. I don't mind spending the money at my company to buy the tool. Now, I don't have those in everybody's trucks. When someone needs one, we'll usually rotate it, you know, the one that we have around, right? If we had a need for a bunch more, then I'd pick up more. But we only have one right now. We're a small company. But I just subsidize the tool when I sell the fittings, okay? I'm not going crazy, but every time I sell a fitting, there's a couple extra bucks in each fitting to help subsidize my tool. Just like I have a recovery fee when I recover refrigerant. It pays for the tank, it pays for a filter dryer, and it pays for a little bit of wear and tear every time I do a recovery on my machine. So when it comes time to buy a new machine, I've got the money. It's already built into my pricing structure. Same thing with the Cormax tool. Yeah, it's expensive, okay? But so is everything else, right? And it's just another tool. If you come up with an alternative to the Cormax tool, then and it's better, then I would consider buying it. But for now, that's the only one we have. It's not my favorite tool. There's a lot of things that I would do to redesign it, but right? Anyways, I like using it. So you can pick those up at truetech.tools.com. Truetech.tools.com is a tool website that I use. I have an affiliate program set up with them. If you use my offer code Big Picture, one word, at checkout, you can get a discount on majority of the items on their website. So go over there, check out the Cormax tool, put in my discount code, and see if you get a discount on that one. I'm pretty sure you do. Don't know 100% sure for sure. But you know, when you do use my discount code, it's an affiliate code. So I get a small commission and you still get a discount. So that's another great way to help support the channel if you're interested in doing so. If not, it's all good. Okay. I'm going to keep making these videos. I really appreciate you guys. Again, shoot me an email, leave me comments, let me know what you think. And if you're looking for a job, shoot me an email because I'm always looking for good techs and possibly an apprentice right now. I'm actually going through a round of interviews in the next couple days. So stay tuned. But yeah, shoot me over your information. Again, thank you so very much. I really do appreciate you. And we will catch you on the next one.